You probably already know that metabolic acidosis can be of two types, NAGMA and HAGMA. First, you understand what is an ion gap. Positive ions minus negative ions. You may include potassium here, but it's not very consequential. And know that these anions, chloride and bicarbonate, are the ones that we can actually measure in the serum. There are other anions which cannot be measured. And because of this unmeasured anion, normally also we're going to have an anion gap which is 8 to 12 milliequivalents per liter. This is NAG. But what if we have NAGMA? That is, in metabolic acidosis, the anion gap is remaining normal. That is, it is being maintained by something. Metabolic acidosis is basically loss of bicarbonate, right? Could be because of losses like diarrhea, vomiting, or a colostomy. This drop in bicarbonate is actually being compensated by chloride. So chloride increases. And this is called hyperchloremic metabolic acidosis. This is your NAGMA. It's also seen in renal tubular acidosis, which you know to be a functional disorder of the tubules. Normally, the renal tubules retain bicarbonate and excrete H+, but since they're not able to function, HCO3 will be lost in the urine. NAGMA can also be caused by acetazolamide, which will cause bicarbonate wasting, and sodium chloride overload. Remember all these causes for NAGMA. When we come to HAGMA, put aside what you already know about HAGMA and mud pies. Let's actually try to understand. This anion gap, instead of remaining normal, has become high. Because apart from the unmeasured anions that we already knew of, we have a lot of mystery anions in the blood. Now, this is called acidosis. So now we're talking about a lot of unmeasured, unknown anions, which have been increased. What are these? Let's find out. Think about all your acidotic stuff causing acidosis. You have the ketone bodies, you have alcohol, which could be ethanol, methanol, salicylates. Salicylates are actually metabolized further into toxic acids, so that is the acid here. Lactic acid is definitely there. Lactic acidosis. If there's a patient of renal failure, you will also have secondary to that, you will have uremia, so that is also an acid. Metabolic acidosis is definitely there. Metabolic acidosis means loss of bicarbonate. That means decreased bicarbonate. Here we had a loss of bicarbonate, actual loss of bicarbonate. But here the drop in bicarbonate is because the bicarbonate is actually being used up in buffering all this weird mystery acid stuff, which is because of another cause. Here we primarily had only a bicarbonate loss. All this acidotic stuff can actually be remembered with the help of the mnemonic mud pile. It includes methanol, uremia, DKA or starvation states, ketoacidosis and alcoholic ketoacidosis. We can have paracetamol or paraldehyde. Isoniazid or iron can also cause it. Lactic acidosis, we'll have ethanol or ethylene glycol. Remember S for aspirin or salicylates or ASA. So that's metabolic acidosis for you.